Hello, everyone. Happy morning, happy afternoon, happy evening, whenever this is finding you. I hope it is finding you safe and happy and healthy and not going too crazy from being bored. This is a very new experience for all of us, right? I didn't expect to ever really be making content like this or making videos for all of you like this, but this is going to be kind of a fun new experiment. As you can see, I've got a fancy backdrop going on that's not really the background of what's going on behind me, but I got a cool little program that makes it so. I can change it to space themed, I can change it to all sorts of different cool stuff, but for today we're going to go with a subtle little cool backdrop. I don't know what to call that. Um, I miss all of you. I miss all of you desperately. I miss standing in front of you, teaching, talking about math with all of you, talking about your lives. This has really thrown a whole wrench in our daily lives, but it's certainly going to change the world, and hopefully it'll change us for the better a little bit. Okay, so right now, what I think we need some good old math to cure any boredom we're having, because like I always say, there's no wound that math can't fix, there's no sickness that math can't fix. Math fixes everything. So I know you all feel the same, and I'm excited to get to talk to math with you, even if it's over the internet and even if it's just me recording a video and sending it your way. So let's get talking about math. What we're going to talk about this week, and what I want you to take advantage of this opportunity, is to further your understanding of linear versus exponential functions. These two things is what we've talked about basically all year, especially linear functions. We've done graphing them, we've done solving their equations, we've done all sorts of different things, story problems, everything you could think of about linear equations, we've pretty much dove into them. Exponential functions we've spent some time on as well. It may have not been quite as much time, but we did spend some time on them. What I want you to keep in mind today, and what I want you to think back on, is that would you rather project that we did at the beginning of second semester. So, if you'll remember, the would you rather project gave you two scenarios. The first one, you were going to get, I don't know, $500 every day added to your bank account. It's a great deal. $500 every day, who would not want that? The second scenario, you would start with a dime or a nickel, or the amounts varied depending on what version of the project you got. But the dime or nickel or the smaller amount scenario, this second scenario would double each time, and it would be multiplied by a number each time, and it would spit out more and more bigger numbers. And actually, a lot of you caught on pretty quickly because you've done a project like this in the past and because you're brilliant. That second option was actually way better because it would grow quickly, especially the bigger the numbers got, whereas the first option was just adding that same old $500 every single time. These really are a linear and an exponential function. Our first scenario was a linear function because we're adding the same thing each time. As you'll see later, a linear function is when you add or subtract the same thing to your outputs or your numbers every single time. The second option, however, was an exponential function because we're taking that money and we're doubling it each time. We're multiplying it by something. In this case, it's 2, because that's what doubling means, but if it were tripling, it'd be 3. If it were quadrupling, it'd be 4. If it were a bajillionating, it'd be a bajillion. So those are the two big takeaways you should look at. A linear function is adding or subtracting each time. An exponential function is multiplying or dividing each time. But we do need to get a little bit more into the details than just that. So let's get going with it. The first place I want to start is that I think we should start with some terms that we might talk about, or terms that you are going to need to know. The first two terms, independent and dependent variable, are things that I may have mentioned a couple times offhand, but it's not something that we really got super into. But they're pretty basic, and we have some other words we use for them that is cool to replace with. So, with independent variable, that is the variable that's the input of your equation. It's the thing you're putting in, or it's the thing you can control. A lot of times in science, we do a lot of experiments, and these two words get used a lot. And as you would imagine with math and science, there's a lot of overlap between those two contents. So let's say I was doing a science experiment and I had 3 plants, and I wanted to measure how pouring different amounts of water into those plants would change the height of the plant as it grew. So the first scenario, let's say I only put a little water in. The second one, I put a medium amount. And then the third one, I just flood that thing and I pour as much water that can basically fit into my watering can. Well, that amount of water, that's the independent variable because we're controlling that. It's what we're putting into the system, or it's what we're putting into the equation. On the other hand, the dependent variable would be the output. It would be the thing that's coming out. So in this scenario, it would be the height of the plants that are growing, because it depends on the amount of water. If I put just the right amount of water, I'm going to get a healthy looking plant. If I don't put enough, that plant will probably die. If I put too much, that plant will probably drown. Not good stuff. So at the end of the day, what you need to remember when it comes to algebra and math is that the independent variable is the input, independent in, that's how I always remember it, very simple way, independent input, and then the dependent is the output. It depends on your input, so therefore it has to be the output, okay? When we're talking about these inputs and outputs, we use two other words to kind of talk about them. The first one, relation, it's pretty important. We just need a basic definition of it, and that is basically that it's a mathematical relationship between two things. What that relationship is, we may not know. There may be more details to it that we don't really know, but we can always look at something and say, yeah, that's a relationship, or that's a relation. I've got two things. I could kind of plot them on an XY axis, which is two variables that we're comparing to each other, and cool. A function, on the other hand, is much more specific. It's where we take a relation, we've established that these two things have some sort of correspondence, and we realize that every single input only has one output. Okay, so if I plug 2 in, I get 4 out every time. I don't want to plug 2 into this thing and get negative 18 because that does not work. That's not a reliable situation. That's not a function. Oftentimes when I talk about this, I'll talk about a vending machine. And I'll talk about a scenario, well, me and my buddy, we're having our lunch, we're getting a little parched, and I decide to be a good friend and go and get us some sodas. And we both want Coca-Cola, so I walk up to the vending machine, I press Coca-Cola, a Coca-Cola comes out. Input is pressing the button, output is the soda. I press it again, input again, pressing the Coca-Cola button, output again, getting a Coca-Cola out. That would be a function. That's a vending machine, that's how that works. That's great. It would not work if I went up and I pressed Coca-Cola and I took a Coca-Cola, then I pressed Coca-Cola again and a Mountain Dew came out. Well, now I got to go back to my buddy and explain to him why I have two different sodas and how if we both wanted Coke, and I'm going to keep the Coke and I'm going to give him the Mountain Dew. Okay? A function is a relationship where if I put something in, I get the same thing out every time. Okay? That's the very, very important part about relations and functions, and especially what makes a function a function. So, a little bit more detail, a little bit more specific. Let's talk about linear functions. Linear functions are what we have talked about endlessly this year. We have spent all of first semester and even going into some second semester talking about linear functions. You should be able to recognize a linear function immediately, no matter what representation I've given you, but let's look at it. So a graph is a straight line. You should look at that first graph on that page and say, yeah, oh yeah, for sure, that's a linear function, that's a y-intercept of 4, I can figure out the slope, da-da-da-da-da-da-da. Okay, so a graph is a straight line, there's no bends in it, there's no curves in it, there's no anything crazy going on with it, straight line. A table is where we have consecutive outputs increase by the same amount. So that's called the slope. So if you look on the left-hand side of my table over there, my x column, I have 0, 1, 2, 4, 5. It's important to notice that 3 is missing from that table. On my outputs, I have 1, 4, 7, 13, and 16. You'll notice if I go from 0 to 1, that's a difference in 1 in our x's, and then 1 to 4 is a difference of 3 in our y's. Cool. Now if I go from 1 to 2, again, a difference of 1 in our x's, I go from 4 to 7 in our y's. Again, we're adding 3. Perfect. That is a function. That's the way I want it to work. It's got a slope of 3. It's increasing by 3 for every 1 we put in. Then, when we go from 2 to 4, well, that's an increase in 2 in our x value. So therefore, when you're thinking about it, the increase in our y shouldn't be 3. It should be double that, which would be 6. Okay, so from 7 to 13, that's 6. There you go. So a table, you'll see those consecutive outputs have the same difference between them each time. Speaking of a common difference, we also can look at the relationship between a linear function and an arithmetic sequence. We talked about two different sequences in algebra this year, arithmetic sequence and geometric sequence, and they relate very well to the two types of functions we're talking about today. An arithmetic sequence is where we're adding or subtracting each time, and you'll notice in the bottom right I have an example of that where we're adding, again, 3 each and every time, and we can figure out what the next number is. So 13 plus 3 would give you 16, so on and so forth. We can keep on figuring those things out. That's why an arithmetic sequence and a linear function are so related, because we're adding or subtracting every time. Okay, so those are the relationship between those two. Finally, we have equations of linear functions. Almost for the entire year, we've talked about them in terms of y equals mx plus b, or slope-intercept form, where y is our output, our m is our slope, x is our input, and then b is our y-intercept. So in the case of our graph up there, our y-intercept would be 4. There are other representations of linear functions. We have different types of equations that we use to do certain different things, but in Algebra 1, really what I need you to focus on is y equals mx plus b. I don't want to confuse you with all that other stuff. I want you to keep it straight up and easy, okay? That's linear functions in a nutshell. Exponential functions are pretty similar, but they have some very key differences that we should talk about. Once again, they're functions. We can represent them with two variables comparing each other, and they have one output for every input that goes in, but the big differences I've highlighted. Mainly with graphs, the big one is that this is a curve. No longer is it a straight line. If I gave you point A and point B, you could connect them with a ruler and be cool. That is not how it works with exponential functions. You need more than 2 points in order to graph these things, and oftentimes you need way more than 2 points in order to get a really good looking graph. But you'll notice this thing has a curve. Its y-intercept is at 1. It looks like it's multiplying by 2 every time to get to the next couple numbers. Similarly, we can look at our table again that's in the bottom right corner, and our x values are going up by 1 each time, but our y values, or our f of x values, side note, remember, f of x, y, those are basically the same thing. You could always pretty much interchange them as long as you have x and y and they're within the realm of Algebra 1. Those things are interchangeable. So you'll see in our table, our f of x values aren't going up or getting added to the same time. 7 plus 7 would give you 14, but 14 plus 7 doesn't give you 28. Instead, we have to look and we have to multiply each time now. 7 times 2 gives us 14. 14 times 2 gives us 28, so on and so forth. That's like that second scenario I talked about with your Would You Rather project. It's doubling, so that's multiplying by 2. Same thing here with our table and our graph, actually. Again, sequence. This is a little bit different than our linear function, which was an arithmetic sequence. A geometric sequence relates to exponential functions. So as you would imagine, again, instead of having a plus something each time, we're getting a multiplying by something each time. And that's what that r number is, or that r variable is in our geometric sequence picture over there. R is our common ratio, or what we're multiplying by each time. So in the case of our graph and our table and our Would You Rather project, that r value would be 2, because the common ratio that we're multiplying by each time is 2. So that's how a geometric sequence and an exponential function are related. Finally, we have the general format of an exponential function. We have y equals a, which would be our y-intercept in this case, times b to the x power. Big important part of exponential functions. The x is up in the exponent. That's what makes it an exponential function. Always you can notice that x is up there in the corner or in the exponential spot, because that is what makes it an exponential function. I know that's kind of repetitive, but it's a point you need to realize about exponential functions. So a is our y-intercept here. B is our growth or decay value. So I talked about how exponential functions are multiplying or dividing. When they're multiplying, we call that growth, because they're getting bigger. It's like when you invest in a scenario, you want it to be growing, you don't want it to be going down. And going down would be an example of decay. So that's where oftentimes my car, for example, I bought it a couple years. It's just a Toyota Camry. It's probably going down in value, sadly. But if I had bought a Mustang back in the 90s or something, I'm not a car guy, I'm so sorry if I'm butchering all this, you all could yell at me, then it would actually be growing, because those things get more and more valuable as time goes on. So when it comes to cars, it's a little bit confusing. I'm always confused. I can't even put gas in my own tank. But back to exponential functions, you'll notice graph is a curve. Geometric sequences are what's related with these. Our output values, are being multiplied each time instead of being added or subtracted to. Multiplied or divide, again. That's about it for linear versus exponential functions. The big highlights are that linears, adding or subtracting each time, exponential, multiplying or dividing each time. I swear, if you remember those two things about that is the big takeaway from today. But that is where we're at. You have all this other information. This is a recorded thing, so you can revisit it at any point in time on the YouTube channel. And if you would be so kind as to check out the Google form that I am putting on our Google Classroom, then you will be able to answer some questions about this. Give me a little feedback on this video. I want to know how it goes. I think this is going to work for us in the future, but I want to know if it works for you. I find always having a pre-recorded something that I can tune into at my own time, especially in crazy times like these, it's a little bit easier for me than maybe tuning into a Zoom meeting or something like that. I'm still available to answer all your questions. Shoot me an email if you have any. If you need more questions or you want to set up a Zoom meeting, that's easily something we can do. I'm available a lot during the day. And just refer to my office hours on Google Classroom, as well as when our class could meet. You could always stop by and ask questions then. But again, same as last week, I will open up a question and answer for just our algebra on Friday. But other than that, I hope this video finds you well. I hope it finds you not going insane. I hope it finds you safe, happy, healthy. Please stay home. Please stay home. I know it's hard. We're all struggling with it, but please stay home, stay safe, keep others safe, keep smiling as much as you can. Hang in there, Falcons.